All right, hey everybody. Today we're going to continue talking about the shift cipher and introduce a new cipher also. And we're going to get into a little bit of the mathematics of how it works. So before we do that, we need some background on what we call modular arithmetic. So let's start that now. There we go. All right, so modular arithmetic is something that we're going to be using frequently when we encrypt. So let's talk a little bit about what that is. So modular addition first. So remember when we did the example, the first example of the shift cipher, we said that we were going to shift everything in our alphabet to the left by 4, and that was going to be our cipher with, of course, the key 4. So what we want to think about is essentially taking every letter and adding 4 to it. So in other words, something like A plus 4 is equal to E, since the letter A, when we shifted it by 4, encrypted to an E. But of course, it doesn't really make sense to put letters and numbers together in an equation in that way. So what we're going to do instead is take our alphabet, which again, we are agreeing that we're using the lowercase letters A through Z, and we're going to say that A is 0, B is 1, C is 2, etc., all the way until we get to Z, which would then be 25. All right. So if we take our equation up here, A plus 4 equals E, and kind of change it to this number system, we get 0 plus 4 equals 4, which of course is a mathematical equation that actually makes sense. All right, that's awesome. So instead of saying that we have a shift cipher where we're going to shift everything by 4, we can actually write this as a mathematical function. So we take an input X, which is of course a plain text letter, but we're going to find the number associated with that. And we're going to input that to the function, and the output is we do that number plus 4, and that gives us the ciphertext letter. Okay, so that linear function describes the cipher that we had previously represented using a table. All right, so for example, if you're counting, remember A is 0. That leads us to J, which would be 9. When we do 9 plus 4, we get 13, which corresponds to N. So J encrypts to N. 9 plus 4 equals 13. Those things are kind of matching up and making sense together. So that's all well and good. All right. But we do run into a little bit of a problem when we get to the end of the alphabet. So if we look at, for instance, the letter W, which is 22 in our system, if we add 4 to that, we get 26. But remember that we said Z was going to be 25, so it doesn't really make sense to talk about 26 in this case. But if we go back to the previous table, we know that W should encrypt to A, which is 0. So what we want to do is basically not work in the regular number system, but in a different number system where this equation, 22 plus 4 equals 0, is true. Because that means that the letter W, when we apply the shift cipher by 4, it would encrypt to an A, which is exactly what we want. Okay, so this kind of number system exists. It's called modular arithmetic. And specifically, we are working modulo 26. The number 26 is called the modulus. And of course, it's 26 in this case because there are 26 letters in the alphabet, right? A through Z. Okay. So when we're doing calculations this way in modular arithmetic, we need to indicate that we're working mod 26. And we do that by simply writing the equation as we normally would, and then just tacking on mod 26 at the end. And again, that just tells the reader and tells each other that we're working mod 26. All right, so 25 is of course a Z. So 25 plus 4, when we encrypt that, it goes to 3 mod 26 because Z encrypts to D. And I'll let you go back and check that on the table if you want. So this is kind of weird. 25 plus 4 you normally think of as 29, but we're saying that it equals 3 mod 26. All right, this is the same thing as saying that 29 is actually equal to 3 mod 26. All right, so in general, how do you do that sort of calculation mod 26? The examples that we've done so far, we were able to kind of figure it out by thinking about what the table looks like and what happens when we shift the letters by 4. But in general, if you're trying to add modulo 26, you're going to add a plus b as usual. So just add your two numbers, divide the result by 26, and the remainder is your answer. That's, I guess, technically the mathematical way to put it. It's a little bit easier maybe if you add a and b together, and then just, if you get an answer that's between 0 and 25, you can just stop. If you get an answer that's 26 or bigger, you will want to subtract 26 until you get down within the range of 0 to 25. So remember, if we're working mod 26, you can think of that as being the alphabet A through Z, which is corresponding to the numbers 0 through 25. So if we're working mod 26, all of our answers should be between 0 and 25. So basically, the function that I mentioned before, f of x equals x plus 4, is going to be a mathematical function that describes our shift by 4 cipher, as long as we say that that function is defined modulo 26. All right, so I'm going to have you guys take a quiz after you watch this video to practice some modular arithmetic. So evaluating each expression mod 26. Again, you're going to add these numbers together and then just subtract 26 until you get to a number or a result that happens to be between 0 and 25. All right, so those are going to be on your quiz in just a minute. If you do something like 5 plus 8 and get 13, 13 is already between 0 and 25, so you don't have to do anything to that one. All right, but let's briefly talk about negative numbers. So any positive integer that you have can reduce mod 26 to a number 0 through 25. Like I mentioned, you just keep subtracting 26 until you get into that 0 to 25 range. But what about negative numbers? So let's just take negative 3 for an example. We know that negative 3 plus 3 is equal to 0. We want to basically find out what is the equivalent of negative 3 if we're working mod 26. So we want a number that when we add 3 to it, we get 0. So what does that mean? Well, if you think about it, if you put a 23 here, 23 plus 3 is equal to 26, but that's outside of our range. So we would subtract 26 to get back down to 0, which is in our range. So 23 plus 3 is equal to 0, mod 26. And that means that negative 3 and positive 23 are equivalent, or they're equal, mod 26. All right. So again, more practice that you're going to do in your quiz. I'll help with the first one. So negative 8, how do we kind of convert that to a positive number, mod 26? So notice here that negative 3 was equal to 23, but it's also the case that negative 3 plus 26 is equal to 23. So basically, we can just take a number like negative 8 and add 26 to it, which gives 18. So negative 8 is equal to 18 mod 26. All right. So I'm going to ask you to do the same for negative 20 and then work on subtraction mod 26. So in this case, if you get a negative number, you're going to want to add 26 to it until you get into our range, 0 to 25. All right. One more thing, multiplication. Again, multiplication is going to be working mostly as usual, mod 26, but you should know that weird things can happen, and we're going to explore this a little bit more next week. So if you're multiplying mod 26, you're going to do multiplication as usual, divide the result by 26, and the remainder is your answer. Or equivalently, multiply the two numbers together and then subtract 26 repeatedly until you get an answer that's between 0 and 25, and that number is your answer. All right, so again, I'll help out with the first one. Here's some practice. 5 times 8 is 40. So I'm just going to grab my calculator. You don't need anything fancy. You can do it in your head if you want, but I'm just being lazy right now. 40 minus 26 gives me 14. So we would say that 5 times 8 is equal to 14 modulo 26. All right, and then again, I'll leave the rest of those there for you to practice, and you'll put your answers in the quiz. Just a word of warning, multiplication doesn't always work the way you want it to when we have modulo 26. So in particular, use caution, especially with this first one. Soon we will be solving equations modulo 26, and we'll obviously talk about why we want to do that. But any equation that you would like to solve by dividing, you need to be really careful when you're working modulo 26. Also, equations involving squared terms can be a little bit funky, and we also have to be careful with canceling like terms. So just a little word of caution that we are going to have to encounter those things in the future, and we're going to have to be careful with them because we're working mod 26 and we're not working in the usual number system that we're used to. All right. So just as a preview, we say an affine map is a function of the form f of x equals mx plus a mod 26. So notice the difference here from the shift cipher was without this m, but here we're going to multiply the x by the m and then add the a. So we have a multiplicative part and an additive part, which is why I use the letters m and a, and we call that an affine map. So when m is equal to 1, so if you replace this 1, then you just get f of x equals x plus a mod 26, then we exactly have a shift cipher. So the question that we want to answer is, does every affine map correspond to a cipher? And again, we'll explore that next week. The ones that do are called affine ciphers. All right, so the next thing you're going to want to do is to take the practice quiz to practice your multiplication modulo 26, and we will start there on Monday.